Great. Hi, everybody.
Hello.
I'm Khaled from Instabug, and I'm super excited to be here in iOS Tokyo Meetup. I'm an iOS engineer at Instabug. Today, I am very excited to talk about our testing experience in Instabug. Let's see our plan for today. So I will give you a quick introduction about unit test and UI test and our testing experience using Kiwi for while developing our SDK. Then we switch to unit test using XC test, and I will tell you why we switching from Kiwi to XC test. I will talk about our multi-threading test. Then I will talk about our integration test, and then our end-to-end test. Finally, I will talk about Tipsy. Let's talk about unit tests. Unit tests are a way of validation to make sure that your class or method is working fine. When you give your class or your method a specific input, you will receive a specific output. So you are trying to make sure that your class are working fine. As simple as this. Is everything okay now?
Everything's good.
Okay. UI test. UI test is testing your app as a black box, end-to-end testing. It simulates user interaction and can assert a UI element change in to respond to this interaction. When we're starting to test our SDK, we are looking for a framework that can help us to test our SDK. Then we found Kiwi. Kiwi is a BT framework. Easy to write test using Kiwi, easy to mock and stop object, easy to assert on values. But there are some problems with Kiwi that we face. We cannot run a single test. You have to run all tests together in order to see the result of your test. The tests are very slow. We cannot enable the randomized test feature in Xcode 9 because Kiwi are not supporting this feature. Finally, it contributes a lot in writing a bad code. I will tell you. Sorry. I will tell you why it contributes a lot in writing a bad code. Here's a sample of a single test for our code using Kiwi. You can see the number of steps for a single test. One of the metrics that proves that you are writing clean code is testability, but Kiwi eliminates this metric for us. If your code is not testable by using Kiwi, you can write tests easily. So it doesn't show you that your code is bad. So this is one of the problems that Kiwi can cause to your code base. Here, using XC test, you have to make sure that every class is doing a single job in order to write tests easily. The test is to make sure that the delegate is called when the state is changed. You can see here at line, the small lines, okay. First line in the test, the app state recorder is allocated, then we allocate the mock or the delegate that will receive the call when a notification is fired. So the test is so clean and test is very, very readable and everybody can see what the test do. Now I will go to multi-threading test. first we need to make sure that our code is working fine with a specific input and return a specific output. But in some cases, our code crashes due to race conditions or multi-threading, or someone trying to use our code in using multi-thread. So we have to use multi-threading test to make sure that our code is testable and will not crash when someone accesses our code in using multiple threads. The example of modules that you need to use multi-threading test in these modules are like network layer or data store layers, because you can access these elements from different threads, background threads or main thread. Here's a sample of class that we are implemented in our code. This class is implementing a sample observer design pattern. Here we are using multiple arrays to add or remove observers. Since multiple arrays are not thread safe, so we can have crashes like bad access crash, or if you are trying to access this array from multiple threads. Another crash that can happen here if you enumerate on an array while you are inserting a new value. It will crash due to an exception called mutating while enumerating, or enumerating while enumerating. I don't remember the specific exception name. So you have to make sure that your mutable array is thread safe. Here's a single multi-threading test that we are using. This line number 92, test multi-threading with block, and we are calling the object, or we are calling the method that we need to test if it's thread safe or not. Here's a single test that we used. I will go to explain how we are using, how we write this multi-threading test. Here's the code. I know it's a large number of code, but this what we used to do when we're trying to test, to make a multi-threading test in our code. Simply, we are using operation queue with maximum number of operations. Then we run the block of code 1k times. If it's thread safe, it will not crash. If not, it will crash. After that, we depend on thread sanitizer to make sure that our code is thread safe. But before thread sanitizer, we do this. We make an operation queue with maximum number of operations. Then we create the last operation clock. Last operation clock will execute the completion handler when we finish the multi-threading test. Then we create a for loop that will execute the clock 1,000 times in operation queue. Then make a wait for expectation to them. So this one we will calling as self-test multi-threading test multi-threading with clock and timeout and counter if you are trying to use the counter for testing something inside the block. Anyone have any questions till now?
Any questions?
Okay. Now I will talk about integration test. Why we need the integration test? We wrote a large number of tests, but we still have bugs. Until we found the power of integration test. Every class is working fine, but when we're using these classes together, it will not work fine. So we need to make an integration test. We need to make sure that these two classes will work fine together and no unexpected behavior happen. Here is a sample of integration test that we wrote in our code base. It's a sample not in our code base, sorry. We are testing that the integration of network layer and movie list model and movie list presenter and view controllers all are working fine. So at the first line, line 32, we add a mock data to our network layer, and then at line 37, we call fetch movies, and then we assert in the view controller mock that we received the correct data. So we are testing the integration of network layer and model layer and presentation and the presenter layer all in one test. So we now are making sure that these all layers are working fine. This is the power of integration test. If you tested that the network layer are working fine and the model layer is working fine and the presenter is working fine, but when you were trying to integrate all these models together and testing your app, you found a lot of bugs because you didn't test that all these layers are working fine together. So this is the power of the integration test. It helps us a lot into increase the quality of our SDK and to make sure that we didn't broke any features while developing a new feature. After unit test and integration test, you need to simulate what has been shown to the user, a complete flow of a feature. A real end-to-end flow. So we are going to use end-to-end test. In order to test your app as a black box, you have to simulate user interaction, and this is what XC-test did for you. But you need to simulate backend response. You cannot depend on backend to test your app, so you have to mock your backend response. We use third party like Swifter. Swifter is used to mock some request and return a specific JSON. So you can simulate that when you are running this test showing movie name and image name, the first line at line 31 is stop the endpoint/movies and return list of movies JSON to you. So when you launch your app, you should expect that the table view will display all these data that will be found in the list of movies. Here is the power of end-to-end test. You actually simulate what user do. So if your unit test is working fine and the integration test is all green and everything is okay, but when user opens the app, it shows a lot of bugs. So you have to run all these tests in order to increase the quality of your app or your SDK. So now we have three categories of testing that answer three different questions. End-to-end test will answer, does the whole system work fine? And integration test, does our objects work with each other correctly? And finally, unit test, do our objects do the right thing or not? You cannot depend on end-to-end test only because end-to-end test is very slow. Integration test is fast. Unit test is very fast. So you have to depend with a combination between end-to-end test and integration test and unit test. Finally, I will talk about Tipsy. Tipsy, we found that UI tests are far from what users do in a real app because users are not using a single feature only while using your app. So he maybe open timeline 4 times and then go to setting and then log out and then log in again and then go to edit profile. So it is the user always did different flows in different scenarios. So you have to test all these scenarios in order to make your quality is better and better. So we develop our framework to help us to do this testing. So we develop TEPSI. TEPSI is run of a combination of action and validation. So we have 3 objects here: object that does action, and object that saves the state of the state of the app after doing this action. Then we must have a validation to make sure that the action is doing the right job and the right task and no bugs found. So we run all these action and validation for 4 hours or 5 hours, and then if we found a bug, the test will fail, and then we can read logs and found what scenarios that goes wrong when you run these all different scenarios randomly. That is still under development, so you write about 50 tests, and then it's under test. So we are trying to make it better and better. Once we finish TEPSI, we'll make it an open source project, so everyone can use TEPSI, because we think that everybody will need something like this to test his app. Here's a link for a blog post that we wrote for testing tutorials and test-driven development. Here's a link if somebody interested for more details about how we test our apps or our SDK in details. And thank you.
We have some time for questions if anyone wants to ask any questions.
Is this one on? Okay, there we go.
Hi, Khaled. Can you hear me?
Yes.
Cool. I found the talk really interesting. I work on SDKs at a company here, so yeah, I see a lot of similarity in what you do. I have a few questions, but the first one, I wonder what percentage of your development time do you spend on writing these tests?
We spend a lot of time in testing because we know the value of testing. Since we are an SDK, we are developing an SDK, so the quality of SDK has a great value, because no one trusts your SDK if you introduce bugs for his code or make crashes. So you have to invest in tests and invest in your quality to make a valuable product and gain trust of your customers. I think the same for your app. If your app crashes a lot or introduce a lot of bugs, if your app deal with sensitive data, so you have to make sure that your app is functional and testable and did not introduce bugs or crashes for your customers.
Okay. So by
did I answer your questions or not?
More than 50%? More than 70%? Just a rough idea.
I didn't hear you.
What percentage of your development overall, 100%, what percentage is spent on testing, like writing these tests?
I think 50-50.
Okay. So you've got end-to-end tests there, but I couldn't see any tests hitting your actual backend. So do any tests do that?
What do you mean by backend?
So making real network requests to, I assume Instabug sends like crash reports to a server.
Yes, we actually testing that the actual network request is occurred. So we are testing requests for that our SDK send the bug request and the crash request for our dashboard, but also we need to make mocking these requests in another test suite. So
Okay.
When we have two suites that we are making sure that actually network request is sent to the backend, and another one that we stop the request and return specific data and see how our SDK react to these different responses.
Okay, sure. So we don't do UI testing, but we have automated testing with Apium on a sample app for our SDK. Do you have anything like that, or considered anything like that?
Yes, exactly. We have a sample app that using our SDK.
And do you do any automation on it? So Apium is one possibility.
What do you mean by automation?
So it's set outside the application, and it's you write your tests as scripts, and they're run separately.
Can you repeat the game, please? I'm sorry.
It's okay. Maybe I'll ask the question directly later. I'll send you a message.
Sure.
Okay. Maybe someone else has questions. Okay, thanks.
Does anyone else have any questions?
I do.
Uh-huh.
Yeah, my question is, I've tried to wipe the Objective-C part of my brain away. Do you know if there's any Swift solutions? That's what I've found is missing, is a lot of ability to mock in Swift and these type of tools. People say you can just write your own, but do you know of any tools that I can mock and verify on the Swift side that you would recommend?
Using a unit test or UI test?
Using unit tests specifically.
I prefer that you will not use any tool for mocking or stubbing. We used Kiwi for mock and stub object, and you can find another tool in Swift, but I recommend that you do not use any tool for mocking or stubbing, because these tools will hurt your code base and make you write bad code. So if your code is testable, so you will find these you will find testing using XE test is very easy and very comfortable. So please do not use any tools for unit test.
I think you can use OC mock as long as it derives from the subject.
Can you give me example for a case that you want to use OC mock for testing?
So for me, there's two schools of thought for unit testing. I don't want to go too far into this, but I adhere to testing everything within my function and not just the results that come out. So typically any dependency that a class is using, I try to mock it. And when I mock it, then I can verify that calls to those dependencies are the way I expect them to be called. So it makes my tests more robust. Again, two schools of thought. Some people just test the external API and the results coming out. But that's why I would look for some sort of mocking framework.
I can share with you something. Can you see my screen now?
Yes.
Where here. We need to mock the delegate that will receive the call when a notification is fired. So we make an inheritance. So we make an mock object that implement IP state reactor delegate, and inside the delegate method that receives state change, we change the value from is called from false to true, because the default value is false, so we change it to true. Then we assert on this value to be true, to be yes. So I think if we are using these ways of testing, like dependency injection using constructor, or using a property, or using any different ways, so you can test your code base easily. One of the best practice that we are depending on a third party or disk or network layer, you have to use it through a wrapper. This wrapper will help you to test your code base easily through changing this framework and implement your mocked framework in order to test your code base to return a specific value and assert on a specific output. This what we used to do in Instabug. Did I answer your question, or?
Not quite. The reason why I would want to test what's going on is so that side effects don't happen that I'm not expecting. So someone could, inside of your reactor, someone could write a line of code that uses a dependency to do something that is unexpected to you. So this test will pass no problem, but a side effect could happen if we're not testing what is inside the method. This is probably something else that we would want to take offline, but I'd be interested in any suggestions of tools that I could use on the Swift side. So let's take this offline, and we'll talk about this, I guess, through messages.
True, we can take this offline, but can I clarify what the power of this test? Here is an integration test that mocked your network layer, so you can use AF networking, Amplifier, any network layer, and now you can test this network layer using an integration test by inheritance or any other way of dependency injection, and then assert on your values. So this will replace OCMock or will not replace OCMock.
This will help when I'm doing integration tests, definitely.
Yes. So this can replace OCMock because now you can test your code base without testing your dependency, like if networking or Amplifier or any dependencies that you are using. Anyway, let's take this offline, and I'm open to answer all your questions.
Thank you.
Cool. I think we're going to need to move on to our next thing, but thanks a lot for taking the time to give the presentation.
Thank you.